You've already had a second moon. You didn't notice. In September of 2006, a small asteroid, no bigger than a bus, wandered close enough to get caught by Earth's gravity and quietly began orbiting alongside the moon you already know. No headlines, no fireworks. It stayed for nearly a year, then slipped away again in June of 2007, and nobody who wasn't an astronomer ever knew it had come or gone. So the real question isn't, what if Earth had a second moon? Earth already has on occasion, and will again. The real question is, what if the next one didn't leave? Let's be precise about what we're proposing, because a second moon can mean wildly different things depending on size. A moon the size of that 2006 visitor, a few meters across, changes nothing you'd ever notice. You could live your whole life under it and never know. But a moon with real mass, say a third the size of the one we already have, or larger, changes everything. Tides, seismic activity, the length of your day, possibly the tilt that gives you seasons. Physicist Neil Commons, who wrote an entire book on this exact scenario, worked out the numbers, and they are not, by any measure, gentle. So let's give this hypothetical moon a name. Let's call her Una, and let's find out exactly what she would cost us. Say Luna arrives the same way our current moon did once, long ago, settling into orbit roughly halfway between Earth and the moon we already have. Close. Closer than is, strictly speaking, polite. The first thing to break is the water. Two moons pulling on the same ocean do not politely take turns. When they align, new moon, full moon, both moons on the same side, their gravity adds together, and the tides that result are not the kind you walk out to observe from a safe distance. Estimates for a scenario like this put peak tides at up to 1 kilometer high. Not a wave, a wall. Coastal cities would not so much flood as cease to exist in their current form, repeatedly, on a schedule. And this wouldn't stay confined to the water. That much gravitational stress, repeatedly flexing the Earth's crust, tends to wake up things that were better off asleep. Increased volcanic activity, more frequent, more severe earthquakes. The ground itself, it turns out, has tides too. We simply don't notice them because they measure in centimeters, not kilometers. Double the gravitational tug-of-war, and the planet starts flexing in ways it was never quite built for. This is, to be fair, the worst-case version. A large moon, badly placed, badly timed. Move Luna farther out, make her smaller, and the numbers calm down considerably. But even the gentler versions of this story involve tides Earth has never had to deal with before, and an ocean that no longer behaves like the one every coastal ecosystem evolved around. Here's where the story gets, unexpectedly, a little more interesting than pure disaster. You'll remember, because we've mentioned it before, that our single moon does something quietly heroic. She keeps Earth's axial tilt locked at a stable 23.5 degrees, which is the entire reason you get 4 predictable seasons instead of climate chaos. A second moon could make that job easier, or considerably harder. It depends, annoyingly, on where you put her. Two moons of similar mass, both orbiting in roughly the same plane, in the same direction, tend to reinforce each other's stabilizing pull, like two hands steadying that spinning top instead of one. In that arrangement, Earth's tilt could end up more locked down than it already is, not less. But tilt Luna's orbit at a sharp angle to the moon's, and you get the opposite result. The two gravitational influences start fighting each other rather than cooperating, and the tug-of-war can actually amplify wobbles in the axis rather than damping them out. The kind of instability that, over the long run, means more extreme swings between ice ages and warm periods than Earth experiences now. In other words, a second moon isn't automatically good news or bad news for your seasons. It's a question of geometry. Get the orbit right, and Earth becomes more stable than ever. Get it wrong, and you've built a second, more efficient way to wreck the climate. Now the part that affects you personally, every single day, whether you notice or not. How long that day actually is. We've established that the moon acts as a brake on Earth's spin. Every tide she raises steals a sliver of energy from our rotation and hands it to her orbit, which is also why she drifts a little farther from us every year. Add a second moon into that equation, and you don't have the braking effect. you compound it. Two moons raising tides means two sources of tidal friction working on Earth's rotation at once, and, with rare exceptions where their pulls happen to cancel out, the net result is more drag, not less, which means Earth's rotation slows faster. Your days get longer, sooner, than they would have with just one moon quietly doing the work. And both moons, feeding on that stolen energy, drift outward faster than our current moon does alone, meaning the whole system ages, gravitationally speaking, ahead of schedule. None of this happens in a single afternoon. We are still talking in millions of years, the patient arithmetic of orbital mechanics. But the trajectory is clear. Two moons doesn't mean twice the stability. It means twice the bookkeeping, and Earth footing the bill for both. Let's end on the one part of this that isn't, strictly speaking, a disaster. The night sky changes, obviously. Two moons, at different phases, on different schedules, sometimes aligned, sometimes on opposite sides of the sky entirely. Eclipses would get complicated in ways no human civilization has ever had to chart. Calendars, tide tables, entire religious systems built around a single predictable moon would need to be rebuilt from scratch, assuming anyone survived the tides long enough to bother. There is something almost unfair about this scenario. A second moon offers you a spectacular sky and, simultaneously, sends the ocean to your doorstep. The universe rarely gives without also, somewhere in the fine print, taking something back. Which, if you think about it, is really the same lesson the first moon taught us. She stabilizes your seasons and drags at your coastlines twice a day. She didn't arrive to be convenient. She arrived through violence, settled into a compromise, and we've spent 4.5 billion years quietly benefiting from the terms of that compromise without ever reading them. A second moon would simply mean renegotiating the contract. And as it turns out, in nature, better views very rarely come without a much higher bill attached. So, would you want a second moon if you were given the choice? It's tempting to say yes. Two moons in the sky is, undeniably, a better view than one. But everything we've just walked through says the same quiet thing over and over in different forms. Stability is not something you get more of by adding more. It's something you get by getting the balance exactly right. And Earth, as it happens, already has. One moon, one sun, one planet tilted at just the right angle, spinning at just the right speed. It sounds unremarkable. It is, in fact, spectacularly rare. We already had a second moon once, briefly, in 2006. It came, it orbited quietly for a year, and it left, without asking permission or causing any damage. Perhaps that's the correct amount of second moon. A visitor, not a resident. If you want to see what else in this solar system is more delicately balanced than it looks, subscribe. Next time, we go past another edge.